Welcome! In this video, we are going to discover the interface of Akabak in its two simulation methods. Let's start with the interface. Akabak is split into four main parts that we're going to use bit by bit during the next tutorials. The top bar is the main menu. It hosts all the functions of Akabak, and the split buttons below are shortcuts to some of the most used functions located in the main menu drop-downs. On the left side, different pages can be accessed with the help of the tab headers. These pages list the elements that are displayed in the center part of the interface. On the right side, three pages can be accessed and host different utilities that are only useful to control the display state of the center part of the interface. Finally, the status bar at the bottom displays a lot of useful information on the state of Akabak, as well as some settings. You can find, for example, the amount of CPU that Akabak is allowed to use that we have set to max in the previous video. Moving onward, we will now see the two methods Akabak uses to make acoustic simulations. The first one is called LEM for Lumped Element method. It works by simulating electric and acoustic properties of different components selected together in a schematic editor. It, however, has some strengths and weaknesses. The LEM is very easy to use, calculations are almost instantaneous, and systems can easily be duplicated to make acoustic responses of multiple cabinets. On the other hand, LEM is a bit too theoretical since the components are considered perfect and without any bend, so I would not recommend simulating cabinets supposed to play above 150 Hz with this method. The second method of simulation is called BEM and stands for Boundary Elements Method. It directly relies on 3D models and works by calculating acoustic properties of 3D shapes. In this sense, it also allows investigation of the acoustics of rooms. This method also has strengths and weaknesses. Since it uses 3D shapes, you will need to use a 3D CAD software to set up your simulation project. The CAD software needs to be able to export step files formats, and for this reason, the popular SketchUp tool is not an option. In this tutorial, I will be using Onshape, which I recommend for their premium hands-on approach learning center. In BEM, it is also very long to simulate multiple cabinets, and calculation takes a lot of time to resolve. In fact, the finer or complex the 3D model is, the longer the simulation takes to complete. By experience, the fastest calculations I've had were about 5 minutes long, and the longest took 29 hours, during which the CPU and RAM were saturated. On the positive side, since you can basically input any shapes, it is much more accurate than LEM, above 150 Hz. It can be used, for instance, to create horns and face plugs for medium and high frequency cabinets. In the next videos, we will be discovering the LEM interface by setting up together Akabak projects.